Here's what I think is a better explanation.
Global warming, or none like it hot. You're probably wondering why your ice cream went away. Well, Susie, the culprit isn't foreigners, it's global warming.
Global wobble?
Yeah. Meet Mr. Sunbeam. He comes all the way from the sun to visit Earth.
Hello, Earth. Just popping in to brighten your day. La 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 la. And now I'll be on my way.
Not so fast, Sunbeam. We're greenhouse gases. You ain't going nowhere.
Oh! Ah! Oh! Ah! Oh! Oh, God, it hurts!
Pretty soon, Earth is chock full of sunbeams. They're rotting corpses heating our atmosphere.
How do we get rid of the greenhouse gases?
Fortunately, our handsomest politicians came up with a cheap, last-minute way to combat global warming. Ever since 2063, we simply drop a giant ice cube into the ocean every now and then.
Just like Daddy puts in his drink every morning. And then he gets mad.
Of course, since the greenhouse gases are still building up, it takes more and more ice each time. Thus, solving the problem once and for all.
But...
Once and for all!
This is the image that started me in my interest in this issue. And I saw it when I was a college student because I had a professor named Roger Revelle who was the first person to propose measuring carbon dioxide in the Earth's atmosphere. He saw where the story was going after the first few chapters, after the first few years of data. He intuited what it meant for what was yet to come. They designed the experiment in 1957. He hired Charles David Keeling, who was very faithful and precise in making these measurements for decades. They started sending these weather balloons up every day, and they chose the middle of the Pacific because it was the area that was most remote. And he was a very hard-nosed scientist. He really emphasized the hard data. It was a wonderful time for me because, like a lot of young people, I came into contact with intellectual ferment, ideas that I'd never considered in my wildest dreams before. And he showed our class the results of his measurements after only a few years. It was startling to me. Now, he was startled and made it clear to our class what he felt the significance of it was, and I just soaked it up like a sponge. He drew the connections between the larger changes in our civilization and this pattern that was now visible in the atmosphere of the entire planet, and then he projected into the future where this was headed unless we made some adjustments. And it was just as clear as day. After the first 7, 8, 9 years, you could see the pattern that was developing. But I asked the question, why is it that it goes up and down once each year? And he explained that if you look at the landmass of the Earth, very little of it is south of the equator. The vast majority of it is north of the equator, and most of the vegetation is north of the equator. And so when the northern hemisphere is tilted toward the sun, as it is in our spring and summer, the leaves come out and they breathe in carbon dioxide and the amount in the atmosphere goes down. But when the northern hemisphere is tilted away from the sun, as it is in our fall and winter, the leaves fall and exhale carbon dioxide and the amount in the atmosphere goes back up again. And so it's as if the entire Earth, once each year, breathes in and out.
So he started measuring carbon dioxide in 1958. And you can see that by the middle 60s, when he showed my class this image, it was already clear that it was going up. I respected him and learned from him so much. I followed this. And when I went to the Congress in the middle 1970s, I helped organize the first hearings on global warming and asked my professor to come and be the lead-off witness. And I thought that would have such a big impact, we'd be on the way to solving this problem, but it didn't work that way. But I kept having hearings, and in 1984 I went to the Senate and really dug deeply into this issue with science roundtables and the like. I wrote a book about it, ran for president in 1988, partly to try to gain some visibility for that issue. And in 1992 went to the White House. We passed a version of a carbon tax and some other measures to try to address this. Went to Kyoto in 1997 to help get a treaty that's so controversial, in the U.S. at least. In 2000, my opponent pledged to regulate CO2, and then that was not a pledge that was kept. But the point of this is, all this time, you can see what I have seen all these years. It just keeps going up. It is relentless. And now we're beginning to see the impact in the real world. This is Mount Kilimanjaro more than 30 years ago and more recently. And a friend of mine just came back from Kilimanjaro with a picture he took a couple months ago. Another friend, Lonnie Thompson, studies glaciers. Here's Lonnie with a last sliver of one of the once mighty glaciers. Within the decade, there will be no more snows of Kilimanjaro. This is happening in Glacier National Park. I climbed to the top of this in 1998 with one of my daughters. Within 15 years, this will be the park formerly known as Glacier. Here is what's been happening year by year to the Columbia Glacier. It just retreats every single year. And it's a shame because these glaciers are so beautiful. But those who go up to see them, here's what they're seeing every day now. In the Himalayas, there's a particular problem because 40% of all the people in the world get their drinking water from rivers and spring systems that are fed more than half by the meltwater coming off the glaciers. And within this next half century, those 40% of the people on Earth are going to face a very serious shortage because of this melting. Italy, the Italian Alps, same site today. An old postcard from Switzerland. Throughout the Alps, we're seeing the same story. It's also true in South America. This is Peru 15 years ago, and the same glacier today. This is Argentina 20 years ago, same glacier today. 75 years ago in Patagonia, on the tip of South America, this vast expanse of ice is now gone. There is a message in this. It is worldwide. And the ice has stories to tell us. My friend Lonnie Thompson digs core drills in the ice. They dig down and they bring the core drills back up and they look at the ice and they study it. When the snow falls, it traps little bubbles of atmosphere, and they can go in and measure how much CO2 was in the atmosphere the year that that snow fell. What's even more interesting, I think, is they can measure the different isotopes of oxygen and figure out a very precise thermometer and tell you what the temperature was the year that that bubble was trapped in the snow as it fell. When I was in Antarctica, I saw cores like this, and a guy looked at it. He said, right here is where the U.S. Congress passed